Hi there. So in this video, we're going to look at adding and subtracting rational expressions. The three specific items that we're going to look at will be adding and subtracting rational expressions that have a common denominator. Then we're going to practice getting a least common denominator so that we will be able to add and subtract rational expressions that do not start out with having a common denominator. So we'll have to be able to build our own common denominator. I'll just remind you that whenever you are adding or subtracting fractions, you have to have a common denominator, and then you add or subtract that numerator, keep the denominator, and then simplify. When your fraction doesn't have a common denominator, you've got to rewrite your fractions, build an equivalent fraction with a common denominator, and then you simplify. So that's what we're going to be looking at here in this set of notes, essentially. All right, so I'll just draw your attention here towards the bottom of the page here, steps for adding rational expressions that have a common denominator. You're just going to, do a quick eyeball check to make sure that each of those fractions have common denominators. Then you're going to add or subtract those numerators, and then put it over that common denominator. Factor that numerator if possible, and reduce, okay, if possible. All right, so I'm going to do this. I'm going to do letter B and C here with you, okay? So you'll notice here in letter B, they have the same common denominator, so we will keep that denominator of 5ab squared. And then up top, we are just adding c plus 7. There's nothing I can do further as far as trying to factor that any further, so that would be my final answer. Okay, letter A would work very similar to that one. All right, let's come over to letter C. Letter C is the same common denominator, so I'm going to bring that common denominator over. And then up top, I'm adding these pieces together. So I'm adding my x's together. So x plus x gives me 2x. 2 plus 12 gives me 14. Now, from here, be sure that you ask yourself, well, can that be factored any further? Do those two terms have something in common? And sure enough, they do. They both have a 2 in common. Factor that 2 out, write what you have left over, and bring that denominator over as well. And then if you can, at this point, cross off any like factors that they have or any factors that they have in common. And sure enough here, they both have an x plus 7 in common, one on top, one on the bottom, so they are able to cancel out. Final answer then is 2 over x minus 8. Okay. All right, now I'll let you pause and try letter A there on your own. Let's flip it on over. And let's look at subtraction here on the next page. So this will work the exact same way. Make sure you've got the same common denominator. But whenever you're subtracting, you want to be sure that you use the distributive property so that that minus sign gets distributed to the entire numerator of that second fraction. And I'll demonstrate that down here for you in letter B. You'll need to factor if possible to be able to reduce in the end, just like you saw us do in that last example. So I'm going to do just letter B here with you and let you try A and C on your own. So you can see I already have that same common denominator, so I am going to write that single denominator then down there by itself. And then up top, it's 5a minus that second fraction. So or that second numerator. So 5a minus, and this is what I meant by distributing. So I'm going to burn a step here and write it like that. Because then, like I was mentioning, this is a -1 sitting in front of there that needs to be distributed. I need to subtract everything in that second numerator. So this becomes then 5a minus 2a, and then -1 times 8. So I'm right, -1 times 2, that's how I was getting my -2a, -1 times 8, so minus 8, all over a plus 6. Let's do a cleanup here. 5 take away 2, so that's 3a minus 8, all over a plus 6. If there was any further factoring that I could do, I would, but here there isn't any, so I am good to go and stop right there. That's my final answer, okay? So just be sure with subtraction that you always take that minus sign and distribute it to the entire numerator behind it, okay? All right, so now let's step it up a notch and let's talk about getting a common denominator. So in this particular example, in example 3 down here, we are just going to focus on getting the common denominator and not going any further past that. But that's going to be important for us to be able to get common denominators so that we'll be able to add and subtract rational expressions that don't already start with a common denominator, okay? So we are just here focusing on getting the common denominator. So what's going to happen here is that you want to factor each of the denominators. If you can, you want to factor those. the least common denominator will include every distinct factor, okay? And you'll include the highest power in that least common denominator. And then you're going to multiply the factors from step 2, leaving your result in factored form. So let's come down here and then demonstrate. I'm going to do example 3. I'm going to do all 4 of these examples because each of them are unique in their own way. And I just want to give you some good practice here of getting your common denominator. All right, so when I get my common denominator here between these two expressions, between, here's a term, trying to get this common denominator here, I'm looking for a number that 7 and 1 will both go into, so you hopefully agree, yep, they'll both go into 7. And then I pick the highest of my letters here. So I've got an A versus an A cubed, so I'm going to need to put an A cubed. I've got a B versus a B squared, I'm going to put B squared. I've got a C, I don't have a C, so I'm going to need a C. So it is here, it's the reverse. It's the lowest number that they'll go into and the highest letters, okay? So it has to be a distinct factor. So and you're picking the highest power of each of those factors. So a number that 1 and 7 will both go into is 7, and then picking out the highest powers of your letters. So A cubed, B squared, C. That would be our common denominator, and we'll practice building from that on the next page in example 4. But right now we're just focused on what is the common denominator. All right, let's move over to letter B. Letter B, I have a denominator of x plus 3 on the first term and x minus 2 on the second term. Neither one of those can be factored any further, so if I were to get my common denominator, then I would need to take that one. And then I ask myself over here, is there anything new and different? Yep, x minus 2 is new and different, so that would also have to be part of my common denominator. So those two terms multiplied together would be my common denominator. All right, so let's move on down to letter C. Letter C is an example where whenever you are going to need to factor first. So I'm going to take both of these denominators here and factor. The only way to multiply to give me m squared, m and m. I'm wanting to think about ways to multiply to give me 48. Then when I add or subtract, it'll give me 2. So the most common way to multiply to give me 48, 6 times 8. I want a negative 2 in the center, so hopefully you agree I got to make that 8 negative and 6 positive, and 6 times negative 8 will give me negative 48. So that's tracking. Let's come over here. Only way to multiply to give me m squared, m and m. Most common way to multiply to give you 16, so that we get a 6 in the center. We think about 8 times 2. I want a negative 6 in the center, so between 8 and 2, which one needs to be negative? We agree that has to be the negative 8 and positive 2. So now when I go to pull my common denominator, I know I'm going to need an m plus 6, and I'm going to need an m minus 8. And then I come over here and I ask myself, is there anything new and different? So I already have m minus 8, so I'm not going to need to write it again, but I am picking up m plus 2 because that's new and different. Okay, so that's what I meant above there about being unique. Okay, so all 3 of those terms multiplied together would be my common denominator. All right, let's scoot over then to the next example, factor. And if you want to, you can pause the video and try this one first by yourself, and then come back and, and check yourself by the solution key, and then if you get it wrong, then come back to the video and hear me explain it. If not, press on to the next example. All right, so here, the only way to multiply to give me x squared, x and x. Most common way to multiply to give you 4, 2 and 2. I want a negative 4 in the center, so I'm getting 2x and 2x. So I can get a negative 4. I'd have to make them both negative. And then negative 2 times negative 2 will give me a positive 4. All right, come over here, x squared, x and x. Most common way to multiply to give me 6, 3 and 2. I want a negative 5 in the center, so I've got 2 and 3. That can give me 5. I need to make them both negative, so I get a negative 5. And then negative 3 times negative 2 would give me a positive 6. All right, so now let's pick up my common denominator. I'm going to need an x minus 2. I'm going to need another x minus 2. Then when I come over here, because essentially I'm going to need both of those because they're in the same denominator. So another way I could write that would have been x minus 2 squared. So I'm pulling the highest power. Okay. When I come over here, something new and different. Yep, I'm going to need that x minus 3. I don't need the x minus 2 because I do already have it accounted for. But when I'm here in the first denominator, I got to take everything that I have. So I've got 2 of them, so I'm going to write both of them there. Then when you get to the second one, ask yourself, is there anything new and different? X minus 3 is new and different, so it gets tagged on. X minus 2 is not new or different, so that's the reason why there. And we'll need another one of those, okay? All right, so let's flip it over to the next page. And let's start here in this example, building our equivalent fractions. Okay, so we're going to rewrite these rational expressions now with a common denominator. So we've already practiced getting the common denominator, so now we want to build our equivalent fractions so that we can take it one step further on the next page and add and subtract whenever we don't have a common denominator. All right, so I'm gonna, here are all of your steps here. You're finding your least common denominator. Determine what factors from that least common denominator are missing from that denominator. Compare your new denominator to your old denominator to determine what's missing, and then multiply the numerator and denominator of the fraction by that missing factor. Of course, I think all of that will make more sense as I show it to you, okay? So we need a number that 18 and 10 will both go into, and it just so happens that they will both go into 90, okay? So number-wise, 90 is my common denominator. All right, so then let's pick our letters. So I've got an a cubed. I know that I'm going to need an a cubed, and the other one just has an a. In terms of my b's, I've got a b versus a b squared. So remember, I'm taking the highest. I'm going to need a b squared, and then I got to pull that c. So then I come over here, a cubed, b squared, c. Okay. Then I'm going to automatically bring down the existing numerators, so the 5c and the 7. Okay, and then from here, I'm just going to do a little parenthesis here. And I'm going to ask myself now, from the old denominator to the new denominator, how did I change? Okay, so here I say 18 times what gives me 90? Because 18 goes in 90 5 times. So I'm going to put a 5 up there because I've added 5 to the denominator. Now from the old denominator to the new denominator, my a's are the same, but I did tag on. I went from b to b squared, so I tagged on a b. And I went from no c's to a c, so I tagged on a c. All right, let's move to the next one. 10 goes into 90 how many times? 9 times. So I'm going to put a 9 there. All right, so from the old denominator to the new denominator, how is it different? So I went from an a to an a cubed, so I've tagged on 2 a's. I went from b squared to b squared, so that's good, and c to c, so I'm good there, okay? Here's what you can do to check yourself. At this point, if you were to reduce and cross out everything that they had in common, you should get back the original, what you started with. Like for example here, if I cross off my a squared, I would just have an a, right? And 7 times 9 is 63, and then if I did 63 over 90 and reduced it, I'd get back to 7/10, for example, okay? Next, so I'm just going to leave it at this stage here, okay? Because all that we're doing here is just building the equivalent fraction. All right, let's move over to B. Let's get our common denominator. So these are already factored here, so then my common denominator is going to have to be, I'm going to have the first denominator. Come over to the second one, that's new and different, so I'm going to need p minus 2. So that's going to be my common denominator, p plus 5 times p minus 2. I'm going to bring down what's existing up there, the 2p and the 4. All right, and now I ask myself, from the old denominator to the new denominator, how did it change? So I already have the p plus 5. I tagged on p minus 2. And then from here to here, I already had the p minus 2's. I tagged on the p plus 5. Okay. The only thing that's going to change differently for us on the next page is that there's going to either be an addition or subtraction sign between those two, and we're going to clean up further. Okay. All right, so let's come on down. Let's do C together as well. C, get my common denominator. It's already factored, so if I'm building my common denominator, I know I'm going to need the a plus 2 and the a minus 5. You have to have what's in the first denominator, and then you come over to the second one and ask yourself, is there anything new and different? Well, I already have the a minus 5, but I am picking up an a plus 3. So there's my common denominator, a plus 2, a minus 5, a plus 3. I'm going to bring down the 7 and the a minus 6. And then I'm going to ask myself, from the old denominator to the new denominator, what got tagged on? And so from here to here, I tagged on the a plus 3. And from here to here, I tagged on the a plus 2. And that would be my final answer there. Okay. All right, so now down below we talk about that what we're going to be doing on the next page is we're going to be adding and subtracting rational expressions with unlike denominators. So essentially what's going to happen is exactly what we just got finished doing here in example 3. Yes, I think this was example 3. Um, what do we just got finished doing here in this example? And after we've built our equivalent fraction, like I said, there's either going to be an addition or subtraction sign, and then we're going to be distributing and cleaning up from there. Okay, so if you will, flip it on over then to the last page. I'm going to do a few of these back here with you. I'm going to start with letter A. And it says add or subtract the following rational expressions and be sure you reduce your final answer. Okay, so in letter A, I want to add these two expressions. They don't have the same common denominator, so I need to get one. So between 1 and 7, they will both go in to 7. So 7's got to be part of my common denominator. I've got an a squared, so I'm going to need that. And then I've got b versus b squared, so I'll pull the highest, so I've got to pull b squared. So 7a squared b squared is my common denominator. I'm going to bring down the existing numerators, which are 4 and 3. And then I'm going to ask myself from the old denominator to the new denominator, how did I change? What did I tag on? So from the old denominator to the new denominator, I tagged on 7, right? Because 1 goes into 7 times. A's are the same, but I added a b down there. Old denominator to the new denominator, so 7 goes into 7 one time, so number is good. I tagged on an a squared. Right? So now from here, I just start to clean up. So now I have the same common denominator of 7a squared b squared. Now clean up. 4 times 7, 28b plus 3a squared. Up top, if they ever had something in common, we'd factor it out and see if we could reduce any further. But in our case here, that's as far as we can go. That's our final answer. All right, let's scoot over to letter B. Letter B, I want to add these two rational expressions together. I can see that they do not have the same common denominator, so I need to build equivalent fractions, getting that common denominator. So I'm going to need the first denominator for sure. Move over to the second one. That's new and different, so I'm going to need both of those pieces in my common denominator, n plus 2, n minus 5. Bring down the existing numerators, 4n and 6. Now ask myself from the old denominator to the new denominator, what did I tag on? So from here to here, I tagged on the n minus 5. From here to here, I tagged on the n plus 2. This one you can really see now what I was talking about a minute ago. You don't want to do this step, but it's a way to sort of check yourself. Make sure now, if I were to cross off what they had in common, so in this case I'd cross off those n plus 5s, I'd be right back with what I started with. And here I'd cross off those n plus 2s, and I'd be right back with what I started with, 6 over n minus 5. That's just sort of a way to make sure that you've got that same common denominator and you've built an equivalent fraction, okay? So now from here, they have the same common denominator, so I can write that denominator of n plus 2, n minus 5. Then in the first parenthesis, or the first term, I'm going to take 4n to distribute it, so that'd be 4n squared minus 20n. And in the second one, I'm going to take 6 and distribute it through the parentheses, so plus 6n plus 12. All right, so let's keep going here. That would land me at 4n squared minus 14n plus 12 over my denominator. Let's keep going because there could be some canceling that can be done. So let's see, up top, all three of those terms have a 2 in common, so let's factor out a 2. That's going to leave me with 2n squared minus 7n plus 6 all over, same denominator. All right, let's factor that trinomial there because it's possible it might have something that can cancel out with the bottom. You want your final answer to be fully reduced. So let's see, if I factor that top, then the only way to multiply to give me 2n squared, 2n times n. Most common way to multiply to give you 6 would be 3 times 2. So let's put 2 in the back and 3 in the front. So that way on the outside I have 4n. Put it up here. Inside I've got 3n. I want a negative 7n, right? That's my middle term here. I can get that by making them both negative. And then on the bottom I have n plus 2 times n minus 5. And that would be my final answer because I get really close, but this one's an n minus 2 and that one's an n plus 2, so they cannot be crossed out. That is our final answer there. Okay. But you want to keep going that step further because it's possible to have things that would cancel out. All right, so let's do letter C here together. You notice here in letter C, you've got a rational expression minus a whole number. In order to do this, I need to make that 8 a fraction, so I can always put a 1 underneath any number, and that still holds it to be true. So now, to find a common denominator, so since I have x minus 3 in the first one, we know we're going to have x minus 3 in my denominator, and there's nothing new and different in the second one, so that's going to be your full denominator there, x minus 3. All right, so now from the old denominator to the new denominator, I didn't change anything there. That's 2x plus 5. From here to here, I tagged on that entire x minus 3. Okay, so far so good. Let's move on down then. I need to take now this, treat this like a negative 8 that needs to be distributed into this parenthesis here. Okay, so I have 2x plus 5, and then negative 8 times x, so minus 8x, negative 8 times negative 3, positive 24 over x minus 3. Let's combine like terms. So 2 minus 8, so a negative 6x plus 29 over x minus 3. And that cannot be factored any further, so that would be our final answer. Okay. I am going to scoot on down and try letter E with you. I'm just trying to give you some good examples of everything so that you can, have lots to, hear and see. But if you're feeling good about it, then try a couple now on your own, and then, you can come back to the video. I'm going to do E and H in the video, okay? All right, so in letter E has the second denominator here that can be factored. You want to do that first, okay, so that you can get the correct common denominator. And the only way to multiply to give you n squared, n and n. The most common way to multiply to give you 15, 5 times 3. We want a negative 2 in the center, so you're going to have to make which one negative? If you agree, that's got to be that 5. It's got to be negative, 3 positive. And then the negative 5 times 3 gives me a negative 15. So I'm just going to mark that part off now. That's my new denominator. So now getting my common denominator, I've got a minus sign on this one. I'm going to need that first denominator for sure, n plus 3. Then I ask myself, new and different, n minus 5. I don't need to add the n plus 3 because I already have it. So then n plus 3, n minus 5. Bring down my existing numerators, excuse me, n minus 7. All right, so now from here, from my old denominator to my new denominator, how did I change? So from here to here, I tagged on the n minus 5. From here to here, nothing got changed, right? It's the same denominator. So now let's keep cleaning up. So I'm going to distribute the n through. So n squared minus 5n. And then here, this is a negative 1 that's got to be distributed. So minus n plus 7 over our common denominator. All right, let's clean up. N squared minus 6n plus 7. All right, let's see if we can factor that top any further. So let's see. N and n, the only way to multiply to give you 7. 7 times 1. We want a negative 6 in the center, so the only way to get a negative 6 in the center, 7 would have to be negative and the 1 would have to be positive. But when you do your double check here, negative 7 times 1 would give you negative 7, and you need a positive 7. So that's the only way to get that negative 6, and those are the only factors of 7 themselves. So that can't be factored any further. So this is our final answer then. Okay. Then I'm going to scoot on down. I'm going to do letter H with you. So down in letter H, I just want to draw your attention to this particular problem. This one can be tackled in a number of different ways, but if you'll notice, we've talked about this before. The only difference between these two denominators is the fact that here in the first one, x is positive. In that one, x is negative. In this one, 4 is negative, and then in this one, 4 is positive. They're complete opposites. When they're complete opposites, it's legal to factor out a negative 1 And when you factor out a -1, then you change all the signs in there, and your x will become positive, and your 4 will become negative. Because think about it, if I distribute that -1 through, I have the same thing, right? -1 times x, that's negative x. -1 times -4, oh, that's positive 4. So what I can then say then is that I could rewrite this now as 5x plus 3 over x minus 4. And the second one, I can change that 23 to a minus 23 over x minus 4. And then I didn't have to really worry about getting a complicated common denominator. The common denominator was really already there for me. And so now my common denominator is already there. It's x minus 4. And I'm left with 5x plus 3 minus 23, or 5x, in this case, minus 20 over x minus 4. That numerator has a 5 in common. Factor it out. Write what you have left over. And then what you're seeing on this one is that then, oh, those x minus 4s, they're the same on top and bottom, so they cancel out. Final answer on that one is just 5. Okay? All right. Again, if you have any trouble with this section, just go see your instructor, go to the math lab, seek out your resources, and thanks a lot. Bye.